All right, what does similar mean? It is not the same. Because if I said, oh, that's very similar, it means
They look alike.
they share things in common, right? But they're not identical. All right, so we're talking about angles in triangles that are similar. So the first one, our blank, say similar figures are the same shape, but may not necessarily be the same size. Similar figures have proportional sides, meaning the ratios of corresponding sides are equal. Okay. So remember when I have a proportion, it's basically a fraction equal to a fraction, right? And if they are equal proportions, it means if you multiply by something, it would be congruent to the second one, right? But I have to multiply. Yes? Okay. So right here, it says, is triangle ABC similar to triangle DEF? What do we think? Do we think they're similar? Do we not think they're similar? They're both triangles. They're what? They're similar, but they're not the same. Okay, so do they look the same? This 90-degree angle is what kind of triangle? A right triangle. Does this one have a right angle? No. So are they the same shape? Well, they're a triangle, but they're not the same type of triangle, right? So no. And if I have 3 to 4 and 2 to 3 and 4 to 5, was there anything I could multiply those numbers by to get to the other number? No. Okay. So my sides aren't proportional. Okay, it says this triangle ABC similar to FGH. Okay, why?
Same triangle, different size.
Okay.
I mean, different.
So let's just say, do we agree that HF is the same as CA? Okay, so I have 2. How would I get from 2 to 4? Times 2. All right, and then I have side FG, which is what? And this is?
5.
So if I multiply that times 2, is it 5? Yes. Okay. So is 1.5 times 2, does that equal 3?
Yes.
Yes. Okay. So I multiplied this side by 2 to get 3, multiplied 2 by 2 to get 4, and 2.5 times 2 to get 5. So it was proportional, right? My sides were proportional. So does that mean it's similar? Yes. Does it make a difference if the angles on the inside are all the same too? Okay, so that question right above it says, what do you notice about the angle measures of the similar triangles? Okay, they both have 90, but what about the other ones? They're all the same, right? Okay, so what about the ones that aren't proportional? They're not the same. So do you think that's going to be relevant and important? Okay, so we notice on the similar triangles, their angles are what? So on my similar triangles, they're all what? Okay. So my angle criterion, it says if 2 pairs of corresponding angles in a pair of triangles are congruent, what does congruent mean? The same, then the 2 triangles are similar. How many angles did it say it needed? 2. So that's saying if it was missing an angle and you only saw 2, but they were both the same on both triangles, then they are automatically similar triangles. Okay? So it says rewrite this in your own words. How would you rewrite that so that you can remember that? Because this says if two pairs of corresponding angles in a pair of triangles are congruent, then the two triangles are similar. What's a way that you could put that a whole lot easier for you to understand? Could you not take out some of those hard words? Are you, if I asked you to reword something, are you going to say corresponding and congruent? No, what do you think you would say? That's the same. Y'all would probably say the same instead of congruent. So if two angles are the same, what? All right, so it says in 1 through 3, use the angle criterion to determine if the triangles are similar and explain your choice. Okay, so it gives me two angles in each one. But do you think that this angle might be this angle? Yes, because that's how they'll try to trick you sometimes. Is it might be the exact same triangle, they just flipped it, right? Because this is the bottom that matches up. So what could I do to figure out just based off of the angles if they are similar? Add them. Okay, so 87 plus 58 will give me what? So 145. So I have to do 180 minus 145. And I get 35. Okay, do those two triangles have two angles that are the same? Okay, I have 87 and 35. So are they similar?
Yes.
Yes. Okay, so I have 60 and 80. What about this one? Okay, what is 6 plus 8? 14 plus a 0. Okay, so 140. So what's 180 minus 140? 40. Okay, so then I have, look, I have 80. That's the only same angle, right? Okay, so are they similar? No. What would this have had to have equaled to be similar? 54. Good. Okay, so Jay's constructed triangle ABC, where the measure of angle A is 53. So I'm just going to draw a triangle. Okay, I'm going to call this A, B, and C. A is 53. B is 112. Bless you. Okay. Ruthie constructed triangle RST, where S is 112 and T is 15. Are they similar? Okay, so what would I do? Okay, I can add, or remember, I can just do start with my 180, subtract the angles it gives me, and it leaves me with 15. So what does that tell me? Why? I have 112 and 15, and I have 112 and 15. So yes, they are similar. They have two congruent angles. Okay, questions so far?
So it's just finding the two similar points.
Right there. And we go to the back.
Is it worse?
Yep.
Please tell
It's
me-
worse.
Oh.
The two angles are congruent. Okay, so if two triangles are similar, we can set up and solve our favorite proportions in order to find missing side lengths. How do you set up a proportion? Do you remember what it looks like? Yes, but you had a fraction equal to a fraction, right? Okay.
No,
So
that's not it.
here's the thing. The hardest part of this is making sure you set up your proportion correctly. Okay. But before we can set them up and see if they're similar, do we need to decide if they are based off of angles? Because if they're not similar based off of angles, I can't set up a proportion because it won't work. All right, so I have 47 and 68. So I'm going to do 180 minus 47 minus 68. And that leaves me with 65. So looking, I have 65 and I have 47. So are they proportionate?
Yes.
Yes. So they are similar. All right. So my proportions. Now, this is where it gets tricky. Okay. You have to pick one to start with. Which triangle are we going to start with? The one on the left or the one on the right?
Right.
Okay. All right. So
I say left now.
you go left to right. So I would start with what I see first. Like you read left to right. Right? All right. So I'm going to start with this side. I'm going to start with EF. So I'm going to put EF. Okay. Well, EF goes from side 47 to 68.
That's the same thing
No,
as
so-
LR.
Okay, it's not LR because that goes from 68 to 65. Which one goes from 47 to 68? Okay, you see how we said EF? E started at 47? So K starts at 47, so I need to go KL. The direction is very important. Okay, and then I have side FT, and it goes from 68 to 65. So FT,
LR.
and then 68 to 65, LR. Okay, so here is where,
Cross multiply.
well, yeah, I plugged the numbers in. So what is the side length for EF?
47.
EF, what's the side length, not the angle,
Oh,
the
15.
side. So 15. What's the side length for FT?
10.
10. Okay,
X.
KL is what?
12.
12. And then LR,
X.
X, I don't know it. How do I solve?
Cross multiply.
Cross multiply and divide. So I have 120 is equal to